Hello everyone, my name is Jelle. Very excited to be here. My talk is going to be about 6LoWPAN and picoTCP and how to support new link layer types. But first of all, I'm going to give a short introduction because and afterwards I'll give a really small demonstration. A bit louder. Yeah, okay. So what is picoTCP? First of all, picoTCP is an embedded TCP/IP stack for the Internet of Things. It's mostly backed by Ultra Intelligent Systems, those guys, and it's developed from scratch with an eye on the Internet of Things revolution. And the first commit was in January 2012, where the three key goals were to make a modular and a qualitative and a portable TCP/IP stack. So, for example, portable, it works with various operating systems on various devices, like for example FOSDEM, which I'll talk in some hours. Supports picoTCP as well. Modularity, every module is so you can switch it on and switch it off, compile it in, compile it out, and that, etc. And also quality is a very high priority on picoTCP. It's published under the GPL-v2 license, but soon it will also be published under GPL-v3, but more on that later. Then about 6LoWPAN. What is 6LoWPAN? For those who don't know 6LoWPANs, 6LoWPAN stands for IPv6 over low rate and lossy personal area networks. What's in the name? I didn't invent it. It's an adaptation layer and optimization layer that doesn't really fit in the regular TCP/IP protocol suite. It's really it's squeezed between the network layer and the link layer, between IPv6 and the 802.15.4 link layer. This is how a regular standard 6LoWPAN stack looks like. UDP as a transport layer, IPv6 with IPv6 neighbor discovery as well. 6LoWPAN, which provides the compression and fragmentation, because those links most of the time have like an MTU of 125 bytes, for example, small MTUs, and so the frames have to be compressed and fragmented because IPv6 have 1,500 bytes in a single frame. So that's what 6LoWPAN provides. But most of the stacks in the available, they only support only 802.15.4, which is really cool, and they also support NOMAC, that you just provide the 6LoWPAN buffer and do whatever you want with it. But I wanted to go a little bit further because there are a lot of new physical radios, radio standards, like Bluetooth has a new standard coming out. Maybe you want it over any radio you want. Want the IPv6 over those radio links, then we should provide the capability to extend it further than only the 802.15.4 standard. So that was my goal, really, to do. Then I'll give a small demo. Fuck code. So unfortunately I couldn't finish a real fancy demo with meshing and everything, because I'm still working on the meshing part, which is a mesh under topology, so it meshes on at link layer level. But now I have a virtual demo. So we have a virtual radio network in picoTCP that can simulate radios, and just to give you a sense of the flexibility of 6LoWPAN and picoTCP, I just set some timer events that changes the MTU of the device for example to 127 to 80 bytes, and later on it changes to 200 bytes, so it's really flexible. And so the 6LoWPAN and picoTCP adapts to that. So I'll first start this. So this is the radio driver. Whoops. Ah, fuck. Wait, I'm gonna compile again. Because the radio driver sometimes is a little bit, yeah, it's not the best. But it works. Allee. Seriously, what the fuck? Come on. Wait. Seriously. Okay. This is embarrassing. Yeah, so the radio, wait, maybe I'll... No, I'm not gonna do this. Okay, but I've added a PCAP driver that yeah, it captures the device's messages that it sends, and so we're now probably going to see yeah, this one. So now, first of all, we have like an MTU of 125 bytes for IEEE 802.15.4. So the fragmentation and the compression layer adapts to that, but after a while, the MTU is changed to 80 bytes. Where is it? Ah, here. And then the adaptation layer, yeah, it compresses it and fragments it further to 80 bytes, and then later, at a later point, the compression isn't needed anymore. So it just it has an MTU of 200 bytes, and it fits inside an entire packet, and it doesn't need to fragment it and compress it anymore. So that's just to give you an idea about yeah, the compression, the flexibility of 6LoWPAN. And so, how does 6LoWPAN and picoTCP look like? We have the IPv6 module, the 6LoWPAN module, which provides the compression and fragmentation, and then we have another module, 6LoWPAN link layer, and this allows to easily interchange the MAC layer, the link layer itself, to provide other support for other devices. By the way, the same application is running at the moment on these two devices. Just a Blinky application that yeah, that's it. How does it work? So when IPv6 wants to send a frame, so we have the IPv6 module on top, then the 6LoWPAN module, and then the 6LoWPAN link layer module. So every module in picoTCP looks like this. Every protocol has its own two queues, like the ingoing queue and the outgoing queue. They can hold multiple frames at once. And then next to that we have the picoTCP stack itself, with the scheduler and everything, and yeah, functions. So if IPv6 wants to send a frame, it sends it to the stack, which enqueues it into the 6LoWPAN queue, outgoing queue. After which, at the moment, at some point, the scheduler calls process out of the 6LoWPAN and dequeues it, and then starts processing it. And what does it do? It first gets the link layer addresses from the neighbor discovery table. Yeah, from the IPv6 addresses, and then it immediately pushes the frame to the 6LoWPAN link layer to check if it fits inside a single MTU, and if it doesn't, the link layer is going to give back the available bytes, and then the 6LoWPAN adaptation layer starts compressing and fragmentation, and then eventually, when it does fit, then it enqueues it in the outgoing queue of 6LoWPAN link layer, the module, and then afterwards the scheduler calls again the 6LoWPAN link layer module to process the frame, and then it goes to the device driver eventually. So that's how it works. The 6LoWPAN link layer itself is based on extensions. So we have several extensions that we can add and remove from the link layer. And so two are currently installed, like picoMesh, which is on which I'm working now, and 6LoWPAN link layer Mac, and they have to provide three functionalities. So estimation to see if they prepend their header for processing, if the available bytes is sufficient for the 6LoWPAN frame that has to fit in it. Process in is just when an incoming frame has to be handled, and process out for an outgoing frame. And so we define a 6LoWPAN link layer protocol structure to make it easily interchangeable for different protocols. And they have to adhere these they have to implement these functionalities. So process in, process out, and estimate I just explained. Estimate is double, sorry. And then address from network, because it has to translate IPv6 address to a link layer address. It has to get it from the neighbor discovery tables or something. It has to know the length of the address, of the link layer address. It has to be able to compare the address, and also to derive an interface identifier, IPv6 interface identifier from the link layer address, which can be derived from the extended universal identifier 64-bit or from 16-bit short addresses. And we define Pico link layer address for that, so that it's a generic version of link layer addresses. Then a Pico device, a 6LoWPAN device, just has two functions. It has to implement send and poll, to transmit the frame on the wire, and poll to see if something has to be done, or an incoming frame there is an incoming frame or something. So if you want to implement 6LoWPAN for your radio, you have to write a device driver first of all, define how you're going to use addresses like EUI 64 extended addresses or short addresses, then write some helper functions, register them in picoTCP with that device on the initialization of that device, and then it just works with that implementation of the link layer protocol, and then you're done. So I have spent a while implementing 6LoWPAN, and I have some thoughts about well, it is actually good 6LoWPAN, because it's kind of weird if you think about it, that it says over IPv6 over low rate and lossy wireless networks, but if for low power, it's kind of weird, because so the entire TCP/IP stack says okay, here's my framing, here's my formatting, IPv6, and etc., etc. And then 6LoWPAN says at once, like, fuck it, I don't care. I'm just gonna remove it all and compress it, and it's kind of computationally expensive to do. So I find it kind of weird that it's so low power. If I think it's more easy to, but. The good thing about 6LoWPAN is that it's standardized TCP/IP feature set you can use. You can use fancy things like DNS, for example, or CoAP, or a cool thing. I also worked on DNS-based service discovery on picoTCP, which is kind of cool. If every device registers their own service and announce it on the network through 6LoWPAN. That would be really cool. And you have these sensors with their own service they can provide, announced on the network. So quite low power applications. Mesh topologies with IPv6 addressing, and also another application would be to bridge different radio links, like I just said. You can also, this device can, for example, support IEEE 802.15.4, but another device with the same stack can use Bluetooth Low Energy, for example. So that's kind of cool to have. And with these different protocols everywhere, this is maybe not that bad, not a bad idea. So this is my final slide. picoTCP is going to have a release next week, which includes 6LoWPAN support and GPLv3 licensing plus GPLv2 licensing, and yeah, that's it. Are there any questions? Yeah.
Don't forget to repeat the question.
Okay.
About the licensing and embedded software and where you have software and you have your own application and sell a product. You have multiple microsoft and GPLv2 and v3. With the linking, because you static link inside firmware.
Yeah.
That's kind of how this works. For example, if we have other company want to use it.
So
you have to open source your application.
So the question is, how does it work with GPLv2 and GPLv3 licensing with static linking on embedded devices? What if applications have to use the GPLv2 and GPLv3 as well? I have to be honest, I don't know a lot about licensing. I know, so I'm maybe gonna give the word to Frederik, who knows.
Will you repeat for the recording then?
Yeah.
In very brief, if you use the GPL version, then yes, you're forced to also open source your code. There is also commercial options available for picoTCP where basically you pay for license, and then you are allowed to keep open source.
So if you make money with it, you pay license and
Yeah, sorry. So if there's also a license for commercial applications, and then if you pay for it, you can use it in your proprietary application. So that's. Any more questions? Yeah.
I have a question about all the compression schemes you're supporting. So there's an old HC1, HC2, there's IPHC.
Yeah.
And you're also supporting next level compression?
Yeah. So the question is, there are different compression schemes in 6LoWPAN, like HE0 and HE-UDP in RFC 4944, but they're a little deprecated, so we don't support those. We support IPHC compression and next other UDP compression we support. It's also in the same RFC, but there is also the generic, which is coming out in. It's a proposal, an RFC proposal, I think. It's already available. Yeah, okay, yeah. So the generic header compression we don't implement yet.
More questions?
Yeah.
Just the helper functions, are they just interfaces they have to do in your device driver to, talk?
Yeah, you can. Yeah, sorry. So the helper functions.
Yeah, is it just interface?
Yeah, it's the interface with a link layer, like. Yeah, sorry. No, here. Yeah, it's the interface with the link layer protocol. So those you can register them with the initialization of the device. So you can assign a different link layer protocol to to a different device. So that makes it, yeah.
Yeah, well, if your development of picoTCP, do you actually do TCP?
Yeah, we do TCP. Yeah, sorry. So the question was, we're called picoTCP. Do we actually do picoTCP? Do we do TCP? Yeah, we do TCP as well, but that's not really advised with 6LoWPAN because they're lossy networks. Their connection, it would be better to use a connectionless protocol like UDP. So a standard 6LoWPAN stack most often uses UDP for that.
You know more or less what's the footprint in memory and energy using TCP instead of using...
I wouldn't know. TCP requires somewhat more. But now with UDP we have, I don't know, around 100k flash, but that's with debugging symbols in. So if we put TCP in, I wouldn't know exactly how much it would add to the stack.
There have been talks about picoTCP in this dev room or in the embedded dev room previous years, which focus on the TCP part and on the memory footprint and size. So you could check those, and then you'll get a lot of figures, and I guess also on your website.
Yeah.
But they are non-related to the 6LoWPAN, which is
indeed,
presented here.
Okay.
Because we support other protocols. We don't. This is just the 6LoWPAN part of picoTCP. It's only a small part. We do much more than only 6LoWPAN. Any more questions?
Okay, thanks a lot.
Thank you.